Hello everyone, today we'll see the principle of recrystallization method. In chemistry, recrystallization is a procedure for purifying compounds. The most typical situation is that a desired compound A is contaminated by a small amount of impurity B. There are various methods of purification that may be attempted, recrystallization being one of them. There are also different recrystallization techniques that can be used, such as number 1, single solvent recrystallization. Typically, the mixture of compound A and impurity B is dissolved in the smallest amount of hot solvent to fully dissolve the mixture, thus making a saturated solution. The solution is then allowed to cool. As the solution cools, the solubility of the compounds in solution drops. This results in the desired compound dropping or recrystallizing from solution. The slower the rate of cooling, the bigger the crystal size. In an ideal situation, the solubility product of the impurity B is not exceeded at any temperature. In that case, the solid crystals will consist of pure A and all the impurities will remain in the solution. The solid crystals are collected by filtration and the filtrate is discarded. If the solubility product of the impurities is exceeded, some of the impurities will co-precipitate. However, because of this relatively low concentration of the impurity, its concentration in the precipitated crystals will be less than its concentration in the original solid. A repeated recrystallization will result in an even pure crystalline precipitate. The purity is checked after each recrystallization by measuring the melting point, since impurities lower the melting point. Then second techniques, another one method, that is multi-solvent recrystallization. In this method is the same of the above, but where two or more solvents are used. This relies on both compound A and compound B being soluble in a first solvent. A second solvent is slowly added. Either compound A or impurity B will be insoluble in this solvent and precipitate, whilst the other of the compound A or impurities B will remain in the solution. Thus, the proportion of the first and second solvents is critical. Typically, the second solvent is added slowly until one of the compounds begins to crystallize from solution, and then the solution is cooled. Heating is not required for this technique but can be used. The reverse of this method can be used where a mixture of solvent dissolves both A and B. One of the solvent is then removed by distillation or by an applied vacuum. This results in a change in the proportion of solvent, causing either compound A or impurities B to precipitate. Then third, another one method also there, that is hot filtration recrystallization. Hot filtration can be used to separate compound A from the both impurity B and some insoluble matter C. This technique normally uses a single solvent system as described above. When both compound A and impurity B are dissolved in the minimum amount of the hot solvent, the solution is filtered to remove insoluble matter C. This matter may be anything from a third impurity compound impurity compound to fragments of broken glass. For a successful procedure, one must ensure that the filtration apparatus is hot in order to stop the dissolved compound crystallizing from solution during the filtration, thus forming crystals on the filter paper or funnel. One way to achieve this is to heat a conical flask containing a small amount of clean solvent on a hot plate. A filter funnel is rested on the mouth and hot solvent vapor keep the steam warm. Jacketed filter funnels may also be used. The filter paper is preferably floated rather than folded into a quarter. This allows quicker filtration, thus less opportunity for the desired compound to cool and recrystallize from the solution. Often it is simple to do the filtration and recrystallization as two independent and separate steps, that is dissolve compound A and impurities B in a suitable solvent at a room temperature. Filter, that is to remove insoluble compound or glass particle. Remove the solvents and then recrystallize using any of the method listed above. Then another one thing is there, seeding. Crystallization require an initiation step. This can be spontaneous or can be done by adding a small amount of the pure compound to the saturated solution, or can be done by simply scratching the glass surface to create a seeding surface for crystal growth. It is thought that even dust particle can act as a simple seeded.